equals type. Okay. All right. Logistics update block to put in the header. And I haven't organized this header at all. That's the other project I'm doing. So I'm very careful to organize the header. There's a little separate section for each file to the extent that that makes sense. Well, I can always violate that if needed. Logi chunk size. Is that not what I called them? Logi chunk size X. Logi chunk size X log 2. Maybe that was what the person was commenting on earlier. No, the one they commented on was in fact the one I fixed. And let's go back to debug build. Okay, yep, so I need these functions. Void logistics. So I need these functions. Okay, yep, so I need these functions. Void logistics free slice. And void logistics create slice. Logi slice s. Let's go ahead and do that too. So, yeah, set s, 0 size of s. Slice x equals x, f0 slice y equals y. And this do I have a, I think I have an SVH. Has to be our count. Oh, I can just mem set that. Oh no, right, I'm trying to free it. If SR chunk of I does not equal null, free SR chunk of I. SR slice X equals 1 to make that invalid. These two mem sets are totally redundant, but whatever. All right, does that compile? Logic instead of logi. That's in this file. And oh, right. No, right, that does work. It's just not show made. Okay, and then what was I just doing? Oh, right. Is this updating the logistics stuff? I can't even tell. I just want to step outside of a 32 by 32 boundary. Okay. No, right, that. Oh, right. No, right, that does work. It's just not show made. Okay, and then what was I just doing? Oh, right. Is this updating the logistics stuff? I can't even tell. I just want to step outside of a 32 by 32 boundary and make sure nothing's like crashing. Alright, so let's check that we're hitting the create chunks about when I would expect. Okay, we created a new chunk here. They should be 8 tall, so I might hit the boundary. Okay, yep. But they're on the 8 boundary. Maybe it should only be 4 tall, because you'll probably make mostly flat stuff. You're not going to build up 8 tall. Well, but you'll start. Yeah, who knows? It's hard to say. All right, so I think that's probably working. I need to do the same kind of logic for the edits now. The edits need to store the same kind of sparse data. Okay. What's in source? All right, so now we need to actually put in some logic. Now the networking is all disabled. So now we need to... All right, so now we need to actually put in some logic. Now the networking is all disabled. I gotta go microwave my food since I haven't been eating. Timestamp of a long. Need some. Okay, so. Okay, so the logistics team wants to push around some. Okay, so the logistics team wants to push around some. Okay, so assuming we, so the logistics. Okay, so the logistics team wants to push around some sprite-y things, so we need some representation of the sprite-y things. What we want of the logistics team want. Okay, so the logistics team wants to push around some sprite-y things, so we need some representation of the sprite-y things. What we want to do is make that as lightweight as possible. So when an ore is on a conveyor belt, or anything is on a conveyor belt, it should just take one byte to describe what the thing is, and then its position is sort of along an imaginary rail along the conveyor belt. And since we have a discrete time step sim at 60 hertz, we can quantize the positions that it can be at. Although the quantization probably needs to be as fine as the sim, assuming we actually update it 60 frames per second. So one thing is every conveyor belt could store all the objects that are in it, although you have to deal with them, the transition as they cross from one to the next. And the advantage of that would be that to traverse the sim in order, I talked about earlier the fact that you have to make sure the objects don't run into each other, and you really want to simulate them from sort of front to back in terms of the directions of the conveyor belts. So storing them in the conveyor belts would allow us to traverse the conveyor belts and then traverse the contents. Another way to do it, though, would be to explicitly construct a sort of route, a sort of map of the conveyor surfaces that they are moving explicitly along. And the advantage of that, one, is that we don't have to sort of do that on the fly, and it will deal better with transitioning between conveyor belts blocks, and there may be some other advantage too. No, the sprites are, well, they're part of the logistics simulation, which is an intentionally dumber simulation so that you can simulate. I was just watching a Let's Play, and somebody had, I think he said 400,000 entities in his world. But I think a lot of them were asleep. A lot of them were not active. And that's possible because you're not putting them through a real physics sim. I mean, in Factorio's 2D anyway, so it's not even a real physics sim anyway, but it didn't use the normal, they intentionally, I posted on Twitter a blog post where they talked about the fact that they used to run it through the regular physics collision detection, and now they made a custom thing that only looks at the next thing on the conveyor belt that it's on. Oh, and the other advantage of that conveyor belt map is that I already talked about the fact that to do that ordering, I need to know where the front of the conveyor belts are. So I kind of need to build that map anyway. And I need to like detect that there's a cycle and do something about the cycle case or whatever. So building that data structure explicitly might be worth doing. Logistics will be the conveyor belts and other stuff like that, and all the Factorio-ish stuff. Logistics will be the conveyor belts and other stuff like that, and all the Factorio-ish stuff. So it'll probably include trains, well, mine carts, you know, whatever the equivalent kind of thing ends up being here. And will include all the simulation that isn't happening in the world, although like in Minecraft Furnace kind of stuff is part of the logistics sim. So what is the right way to do that? Yeah, I think the best way to do this is to just embrace the dynamic allocation problem and build these data structures representing these things. So I actually need to do something a bit like STB connected components, but it needs to be 3D and sparse and store the directionality. But it needs the dynamic updating and all that kind of stuff that I have in that stuff. And it has to be on a large map. So I think what we'll do is we'll do this. We'll make a conveyor belt run is when you have a conveyor belt that's all we'll do is we'll do this. So I think what we'll do is we'll do this. We'll make a conveyor belt run is when you have a conveyor belt that's all pointing the same way, a row of conveyor belts that are all pointing the same way. We'll combine those into one thing. And so then we'll have to find where the connections, where transitions between runs are. So we can do a sort of higher level analysis on that. Maybe in the long run this could include turning corners, but for now it won't. So you could still defeat this if you just did the zigzaggy shape. All right, so all right, so we're going to restrict our world to 32K. 32-bit. We're going to restrict our XY coordinates to 32-bit, rather than have it all computed relatively with higher precision. So what's the theoretical size of a Minecraft? Is a meter. So so that's 2 million miles. It's only like 8,000. Oh, okay, it's 24 million. Okay, more than I was. No, 24,000 miles. Yeah, so yeah, I think 2 million miles is plenty big. Presumably, if I don't let you teleport, I can just make it so that it would take you years to go that far or something. So, wonder what the circumference of Jupiter is. All right, so that will let me just use global XY coordinates. I guess I could. See, the problem is I want to actually allow the conveyor belt runs to cross the chunks. Because if I don't allow them to cross the chunks, maybe I can let them cross the chunks. Because I already need to join them anyway. All right, let's do that. That'll allow me to make this split global and local computation consistently. Actually, I can do all the local computations on the slices. Maybe that will make more sense. So UN8, the X and Y, offset from the slice, and the Z, and then the direction, and the length. It's 5 bytes. And then there's the contents of it, and the contents will depend on its length. Call them belts instead of conveyor belts. Belt item. Actually, let's do this sided. So the type, and then there's a position along the belt. Now, if the belt is packed, if the belt is full, then this position, let's just say it's that, is going to be redundant. If the belt is sparse, well, it's not redundant because they do have sub-belt position. But the sub-belt positioning, we could actually force the simulation to to be sort of quantized, even though it'll simulate every step. We could make that you can only be at a given subpixel precision on a particular subframe. For a particular, like the real tick, the real effective factory tick could be every 4. Like the time it takes for it to move from one thing to the next position, the position of the object ahead of it is n frames, and you could have that n frames, the in between of those n frames, not actually be stored explicitly but implicitly. And then you wouldn't need the finer positioning. You would only need as much positioning for per thing. Yeah, that would be doing 8. Okay. So on a belt of 32 long, we can fit at most 128 items. That's sort of the high concept. So a run that's 32 long would be 128 items. Would need to store both belt side items. Worst case would be that. I'm not saying it would actually be that data structure. That's just, and that would take, if you just always stored it for everything, then you don't need the position, and it would take 256 bytes. If you do store, if you store it sparsely, but they are full, then it will take, so the dense version is always 256 bytes, regardless of length. Sparse is 8 bytes if empty, and 512 bytes if full. Except that's not true. It's 8 plus len times 2 times 4. Okay, so assuming you have lots of short belts, this would be terrible. Now you could store this, not with this data structure, and then it is 1 times 2 bytes regardless of length. So the question is, which is better? To have to keep resizing it, or to just pay that price? I think this price is better. I think this is better. It would be nice if I could pack this. So this is just talking 32-bit sizes. It would be nice if I could fit those both in 4 instead of this one being 5. So the direction is only 4 bits. Z is full size. These are small. So I could bit pack them. This is only, but I'm going to manipulate that a lot. Maybe not. Let's try this. Okay. So then we need to store. No, it doesn't need to be double. It could be single. Okay. So there we go. So now we have to do 2 things. We need to keep track of belt runs, and we need to populate items onto them. And keep track of. So now we have to do 2 things. There we go. So there we go. So now we have to do 2 things. We need to keep track of belt runs, and we need to populate items onto them. All right, so how do we do this? All right, when we update the block, what are those called? Block BLBT. I should make a macro for this. Oh, and its old type might have also been. Split belt this chunk is C. Ooh. All right, so how do we do this? All right, when we update the block, it's called block BLBT. I should make a macro for this. Oh, and its old type might have also been. Split belt this chunk is C. No, we want the slice actually. Right, we store that in slices, not in chunks. Should we store it in the chunks? I guess we should store it in the chunks. There'll be a lot more of them to process potentially, but all right. So we want to split the belt chunk G chunk ask X G chunk. I guess I should just store this because I'm going to keep using it. X. All right, so what we're going to do is first we're going to say any belt run that intersects that needs to be split. And that'll create an empty belt or a single size belt run just for that object. The reason for that is we want to preserve any objects that are on that belt. If we're changing it from one belt direction to another belt direction, we don't want the objects on it to get destroyed. So this preserves it as a belt. Preserves the contents of it. They'll rotate with the belt or something, which is fine. Okay, so now at this point, we want to create a belt at that position. And the direction is BT conveyor east minus type. No, type minus BT conveyor east. And the create function will presumably automatically deal with the various cases here. Okay. So let's start with create belt. So let's start with create belt. So let's start with create belt. So first, let's go and find if there is a belt. If it is a belt by itself. We never have to check for intersecting because we are guaranteeing so we can just iterate through all the belts. So we check if there's already a belt there. And if there isn't already a belt there, we'll create one. To change that from Z to Z off. And B dot X. All right. Or did we say we would just always, did I decide on always allocating it? Yes, so it's not dynamically sized. That is correct. Yeah, I decided to do that. It actually needs two of them, but I didn't want to store two pointers, so it'll interleave them. The two sides will be interleaved. Now this is dumb if it's just going to merge it, but I don't care. Now we have to push that. Okay, so look for other adjoining ones. So we need direction for the facings, which I made a table somewhere in here. Paster. Let's make that public. This will be used in lots of places probably. So if let's run all right. So if x off, all right, so first of all, if a dir equals b dir, that's the first requirement. They have to be facing the same way for us to merge them. Then we want to know if C is at the if B is at the end of A. So if A arrow x off plus face dir of that's just dir, though, right? Because we know B dir is dir. Dir of 0 equals times a len. So we could store that for each belt. We could store its end coordinate to save this computation. The multiplies, because we're going to be doing a ton of multiplies in this loop. Of course, this doesn't need to be a linear loop. We could store some kind of data structure to accelerate it as well. We could store the belts for each z height separately, for example, since they're never going to meet except using ramps. No, this isn't always going to be true because this is a break statement here. So this is a sort of a standard way. Check if the item's in the loop and bail out. This, it's equivalent of all of this code being right here, basically. No, of it not being here, right? That's the case. If this test happens, all of this code is skipped. So it's the equivalent of this doing a goto around all of this code. It's just a common way to write this. And it's just a common thing for when at the end of this, you know you're always going to create one. So either you found an I that existed already, or you're creating a new one, and the I value happens to already be correct. What we actually want is I equals index we just created on last line. But that happens to be the value I already has. The index that we're going to create, we're going to add one new item to this, so it would be the same as saying this. That's the last index we created. Oops, this should be our len. That's why none of this made any sense. Wow, okay, that's really weird. This is what we're actually trying to do, and we moved this one statement earlier before we push the length. Then it's just this, and then that is already true, so we just skipped updating it. But yes, that probably made no sense at all without the len. Although you might have inferred that that was what it meant. Okay, so So if this equals the B position, and Y off, okay, oh, right, so we also require Z off equals B Z off. Dir 1 A arrow len equals B arrow Y off. Then merge run. So it's chunk C. We want to merge I and merge J and then I. We want to return the result into I and break. And then we are going to do another loop. And we could probably do these all in one loop, but I don't want to try to figure it out offhand. So. And now we want to check the other end. We want to check if B points to A, and we could do this by going the opposite of the face direction. We could I could let those as A and said minus. Maybe that's better, so that the parallelism is more clear. And I need to reload B when I do this, because I updated I here. So we have to try to merge this belt with belts on either side of it. That's what this is doing. Did I mean to push that on the array twice? Where do I push it twice? Did I mean to push that on the array twice? Where do I push it twice? Oh yeah, this, I'm populating it with, oh right, yeah, you have to do, there's 2 sides and there's room for 4 items on it. So I'm just trying to fill it with zeros, and I should just str set len becomes 8. But then I also have to mem set it. That's what I was trying to do, basically. I assume there was no other push anywhere. Which now makes me wonder if that's really the right way to do this. Anyway, the merge is going to have to deal with that merging there. And so then we say merge run C of, now it's I and then J. Right. All right, and I'm just reversing these when I let off. And thinking about this, let's not make it use a global variable. Let's, well, it's the same either way. And I don't care about the return value from this one at this point, because I've finished creating once I merge those. All right, so we need to merge. Merge run. So we need to. All right. So we need to merge. Merge run. C int. We need to, where was the split? Oh, the split was this separate one. So, B is always after A. So, let's actually use I and J here again. Oh wait, did I call? Oh my god, I called JA and I called IB. That's so terrible. I'll still likely make a scrub here. I guess I should leave that. Right, yeah. All right. So, run of 5. And that thing I did where I went backwards doesn't work. That doesn't make any sense at all, this minus thing. It does have to be plus and in the opposite direction. I want to know if A ends where B is. Where B starts. Okay. I never got my thing out of the microwave, so I got reheated again. To do it down and okay, so checked all that, and now we say, so what we're eventually going to do is that, and then delete B. And we can delete B by our fast delete, which copies it down over. And we'll need to SBR free B. And we'll need to SBR free B arrow items. Okay, so the first thing we have to do is, where's that for? Items per belt blocks, or belt side. Okay, so BR setlen items. Current length, well, we just know what it is. It's A arrow len plus B arrow len times items per belt side. Maybe someday we'll change our mind and only make it one line, in which case that will be good. Mem copy items plus belt sides, the arrow items, comma, the arrow len times items per belt side times belt sides times size of items 0. Jeez. What's it called? Belt side item. PSI equals so this is where we're going to write it to. Yep. Okay, so now we've copied all the items from B into A. We extend A's length and we delete B. Okay, I think that's it. Runs are not going to span across chunks. Runs are not going to span across chunks. We have to do some global. We want to split the. We're going to have to split things up at some point and do analysis across the splits, like maybe when they change directions. Since we have to do that analysis anyway, if we go ahead and split the belt runs at chunk boundaries and do the same analysis on the large scale, that will be good for incremental updating, because then when we split a very long belt run, we don't have to deal with that very long belt run splitting and that local code. This is the same as what the SDB connected component stuff does. You split it up in a 2-level hierarchy, and when you do an update, you only have to update the little local area and then the global update that's on a source sparser data set, because they represent larger pieces. Okay, so that's merge run. Let's compile. Belt side run now. But it's not a belt side run. It's both sides. Oh, right, belt side item. Okay, so that, what is it? Initializing incompatible types. Oh, it's just missing an address. I don't even read the bug sometimes. Merge run, I forgot to return the result. This can't be avoidant. So we deleted B. So we want to know where A ends up. So to do that, we need to actually see inside the fast delete. All right, so rather than replicate the code, I will leave it fast deleting, but if J, if I was the last, wait, which one did we delete? We deleted B. Oh, right, yeah. So we deleted J, and we're trying to return I. So that, what is it? Okay, so that's percent large, and then the global update that's on a source sparser data set, because they represent larger pieces. Okay, so that's merge run. Let's compile. Belt side run now. So so if I was last, because we just deleted, so if I was last, it's at the end, then we have to return J, return Y. Boy, that's pretty not intuitive. The fast delete swapped some item down, which means the indices don't change unless you're the item that got swapped down. So I think that's right. Cut and paste bug. Well, cut and paste is the same bug. Split belt we have still haven't written. All right. Belt we have still haven't written. Bug. Split belt the same bug. Cut and paste bug. Well, cut and paste the same bug. Split belt we have still haven't written. All right. So we know it's a belt, but we don't know which thing it belongs to. So we have to loop over and find it. And we're going to have to do the same sort of splitting mess. Okay. If and actually we can call the direction. We know which direction it has to be, so we can save a little computation by passing that in. Because we haven't updated it yet. So we can in fact pass in. So we can check if arrow z off equals z and arrow dir equals dir. If arrow x off equals x or arrow y off equals y. One of those has to be true. That's a minimum requirement for intersection. Okay, and then I guess we can switch on the dir first and actually just do it right. Facing east. West. South. I think that's right. This is probably going to be clearer from my mind if I reverse these directions. This one I want to do this way. Okay, if it's west, we want ARX off minus A line less than equal. Yeah, let's just do it consistently less than equal. That'll be clearest. Like that. North, we're going positive is north. Okay. No, because I'm not storing in no, because I'm not storing in the question is about the position. Don't I need to update the positions of the objects that I just copied from one belt to the other belt in the merge run? And the answer is no, because currently I'm using implicit positions where just their position in the array is their position in the thing. And I could change my mind about doing that if I want. But I think that's going to be the most efficient way to make it work. Okay, so if we didn't find it, that's a bug. Because there should always have been a belt run for it. Yeah, if we destroy the block, I didn't handle that case here. else if old type regular BT conveyor east and old type plus equal BT conveyor south. We need to destroy belt. Actually, I don't need that. Rather than store runs, wouldn't be simpler to just store connectivity in bit masks per block? Worried about memory usage? No, I need larger scale info than per block, because when I run analysis steps on higher level things, I want coarser representation to speed up the higher level analysis. If it were just for if you were just simulating, you would just need to know, you wouldn't even need to know connectivity exactly. You would just push your objects in a given direction. Okay, so that's destroyed belt. So I got finished split belt. Okay, so when we get to here, so I got finished split belt. Okay, so that's destroyed belt. So I got finished split belt. Okay, so when we get to here, let's compute what position it is along the belt. Run. That's that, because it's always the front of the belt. In A always has the front of the belt. So I think now I don't need case-based logic at all. I think I can just do it with math. So first we have to split it into two belt runs. Just use a new different naming convention. So E is this one, and actually we just want these to be that. Okay, so first of all, if length is 1, then we don't actually split it. We do nothing. Is that a case that we can hit? Yes, it is. to return. Okay, if it's length. So otherwise, we start a new belt run. Same direction. It starts. Okay, we could have found the one we found. We could be at position 0. But it's possible E is empty in this case, which is kind of annoying because we want to push them on later. All right, let's allow the E run to be turned to 0 length temporarily. We'll clean it up later. That'll make this code clearer. F.len equals and minus pause. F dot x off equals x, F dot y off equals y, F dot z off equals z. And then F dot items, we have to split the items. I have to split the items between those two. These are STB arrays, so we want to just pass in the E and F so it can manipulate those properly. Although we've already set the lengths. Yeah, let's go ahead and let split items set the length. Okay, and then when we get to here, we want to create G. Items FG. That one, no. How many to keep? It's 1. This is the number of items to keep for the first one. Side times belt size. Okay, now at this point, we need to push F and G onto the array, but E arrow len equals 0. And we just overwrite E with F. Else SVR push SVR. Wait. Those are the belt runs. CRBR. F. If G dot len does not equal 0. Oh, right, I was going to have split items set the length. Right. Zero push. I believe that handles all the cases. Whew. So much code doing almost nothing. So I need to add split items. I didn't actually pass in launching chunk. I have to add that. So nothing. Code doing almost so much code doing almost nothing. So I need to add split items. I didn't actually pass in launching chunk. I have to add that. Then I passed in the belt runs, right? Maybe I don't need launching chunk. Yeah, I guess I don't. Thinking about it. Okay, so what eventually we'll have is a len equals num a, therefore b arrow len equals a arrow len minus num a, because we're splitting those. And then we want to SB, we want to do b arrow items equals null, br set len, b arrow items, b arrow len times AR items. And the only problem with this is that doesn't actually realloc downward. That's times items per belt. What was it called? Per belt side. Yeah. Belt sides. Maybe I should have a, since I keep using this, maybe that should be a macro. But before I set it down, I have to mem copy arrow items plus arrow len times items per belt side times belt sides, and the number to copy is b arrow len times items per belt side times belt. I already have this somewhere. I should probably size of arrow items 0. Should probably reuse that. Where's that mem copy? Right, I split this one out because it was so gross. Void move items. Void move items. Belt run A, belt run B. That one is a little different because that's adding on the left for where the other one's adding on the right. All right, fine, I won't share it. Okay, let's belt sides. Let's find that macro and move it up. Side times belt sides. All right. Well, what did I call these? Pause. Destroy bells. I haven't implemented that. All right. Destroy bells. I haven't implemented. Destroy bells. I haven't implemented that. All right. But here I have something destroying about. Void destroy belt raw logic chunk C int I. And what do? We say belt run b equals sb equals address c arrow br of I. SBR free BR items. We are fast delete. Raw C comma J. Okay. Here's a leaky abstraction. We destroy it without knowing the details of it, and then we rely on knowing exactly the details. Rock on. Void destroy belt G chunk C and 1 Z. All right. Close the bracket. All right. I need to add a visualizer. All right. All right. All right. I need to add a visualizer for this, but let's just first see if it crashes. Yay, I tried to append one to an existing one, and we hit an assert because I got the assert wrong. Oops. Right, well, it claims to be updating them. So let's go ahead and add debug rendering. So let's go ahead. Well, it claims to be updating them. It claims to be updating, right? Well, it claims to be updating them. So let's go ahead and add debug rendering. So the way that works is main. When we draw the overlay, it is here. Logistics debug render. Logistics debug render. Logistics debug render. Okay, less than logic cache size. And then we go OK. So logic chunk, logic slice. Sludgy world. We need to knit this. Set to an impossible value. Call that. Okay. So then if s x is not equal by both 1, then we should do the debug rendering. K equals 0, k less than. Okay, now we can look at our belts. Okay, there we go. So, float x, y, x equals z, x equals f0 slice x times log g, cache size y equals slice y times log g, cache size, no, yes. Z equals k times log g. Yes, that's not log g cache size, it's log g chunk size x. Chunk size y. Is logic chunk size z. Okay, so now I believe block coordinates are go from 0, 0, 0 to 1, 1, 1. So the top surface is going to be up. The z needs to be offset by 1.2 or whatever. So since the z is just going to be constant, we can do that here. So now, we can compute our x and y bounds. So x0 is origin. Let's do this. How do you do this? That gives us a 90-degree rotation on it, and then that's what it's called, face dir, offset dir. Faster. Kind of the wrong name entirely. I'm not exactly sure how to do this. That's what X1 is. What's X0? Okay, I gotta actually make a little chart here. Figure this out. If I want to draw a one long belt. And X and Y. 0, 0 is here. So then if I rotate by 1, I need to go up to here. Maybe I need a separate table for this. So if it's going east, we'll make it be 0, 0. And if it's going north, we want it to be at 1, 0. So X0 is face org. Yeah, I need to store the coordinates all separately. It's called. I never use it. Geolines loop? Geoline loop? I'm not going to stick these in variables because it's just going to be too complicated. So, base org. Oh, we can use face org for all of them. Okay. Let's equals face org. What am I doing? I'm attempting to visualize the belts. Why does K go to SB array count instead of SB or line? Because they're actually two totally different things. Our count is, this is a statically defined array. So this is just that size of macro, the size of the whole data structure divided by the size of a single field. I'm attempting to debug render conveyor belt, the internal representation of the conveyor belts. So, and it's just confusing. Unnecessary confusing. Okay, so I don't need to add the face origins here. I need face dir D0. Okay, so I want D1 0 Y plus face dir D1 of 0 1 comma Z, and I want face dir V1 of 0 plus face dir 0, 0 times len y plus face dir. This would be a lot cleaner if I just used the vector math stuff, probably, that I already have. So I have these things to add these offsets. Let me see. X without this. Yeah, let's just do that. You have X, comma Y. Let's see. Here. And then we have this one. This one left out the face here. D1, 1. Should be 0, 1. header file. Oh, yep, you're right. X and Y are going to communicate that because I don't recompute them. Oh, yep, you're right. X and Y are going to communicate that because I don't recompute them. All right, we'll just let the optimizer figure it out. Thank you for catching that. Okay, I'm sure this is not right, but whatever. Oh, yep, you're right. X and Y are going to communicate that because I don't recompute them. All right, we'll just let the optimizer figure it out. Thank you for catching that. Okay, I'm sure this is not right, but whatever. Okay, it's in the wrong spot, and it's... Oh, yep, you're right. X and Y are going to communicate that because I don't recompute them. All right, we'll just let the optimizer figure it out. Thank you for catching that. Okay, I'm sure this is not right, but whatever. Okay, I'm sure this is not right, but whatever. Okay, it's in the wrong spot, and it's... So is that going to be consistently offset, or is that... Or is it drawing all of them in the same place? Why did it turn white at some... Oh, that may just be a fake. No, oh, it's... No, it's turning white. Oh, it's whatever color. That's true. Yeah, yeah, I didn't set the color here. Okay, so I'm never adding the X off. The Z value for that one's wrong. Yeah, you can see it's drawing at the ground there. I don't know where that one's drawing. If it's drawing anywhere. I don't see it. I may be quantizing to the boundary because I forgot to add Z off. Yep. Because I have that same kind of optimization. Alright. So now let's check out the merging. Alright. So now let's check out the merging. Because I assume this is going to be correct now. Okay, yep, and there's no boundary between them. That, and now we'll see if that merges correctly. Yep, it seems to have. Put one alongside, that will get its own thing. Those are independent runs. And then we're going to merge that. Looks good. All right, let's try it. Removing. That did not do correctly. Oh, yep, that blew up really badly. Removing from the end. removing a single thing? Maybe. All right, so removal failed. All right, so removal failed, which is, we get to update. The existing one is there, so we call split belt, and then we call destroy belt. And since destroying the standalone maybe worked, probably destroy belt is correct. So split belt is wrong. I have not done anything about rotation. I have not done anything about rotation. I mean, I have rotated, I can rotate the conveyor belts. It just has there's 4 different conveyor belts. And yeah, I'm only testing one rotation right now for the splitting, for the stuff I just looked at. I'll have to test other directions in a second. Which I should have tested that the visualizer actually even worked for this. I did not do that yet. All right, well, I don't hit the assert, so I'm definitely finding one. I'm going to assume I'm finding the correct one. I may not be computing the position correctly, so let's at least assert that. And then we can even assert that 0 x off plus base 0 equals x search y off plus base 0 1 equals y. So I can check that. Well, we run and check that, but let me look at the code first. So we construct a new f. This is supposed to set both e's len and f's len. Construct a new g, that should update f's len and g's len. If e's len got updated to 0, we replace it with f. Otherwise, we add f to the list. If g was non-zero length, we add g. That all seems reasonable. We update the lengths. Did we need the old length though? I think this. No, okay, right. We haven't actually shrunk the array yet. Oh, I forgot to get my food out of the microwave again. Damn it. All right, as soon as I get this debugged, I'm going to take a minute break or something to do that. To microwave and get it out in the same trip so I don't forget. Oh, I'm using ELN here. That's not right. That should be pause. Or pause -1, actually. All right. So first of all, let's check that the visualization is correct for other rotations. Oh, except that it has to actually try to do this. So it's not even the visualization. Okay, so that doesn't work with rotation. All right, let's solve that one at a time. Let's first stick with the current rotation and check the split. All right, so delete from this end. Okay, that also fails. Oh, I didn't multiply by pause. delete one end. Nope. I've outlined 1 times items per belt. This should just be the length, and it will get multiplied internally. Because it's no longer splitting items, it's actually splitting the belt. So let's call it that. That's a misleading name. I think it was already doing the multiply internally as well. Split belt. Wait, oh, that's already called split belt. Yeah, this is multiplying my items per belt. So next we'll have to actually put items on. So next we'll have to actually put items on. But we need item rendering for that. Okay, delete the end. Nope. Left a little stranded thing in the wrong spot. Delete that end. Nope, left a little stranded thing. Nope, it's all totally broken. It's like offset where it's what it's deleting. Was correct, but I want to make this one down here explicit, because this test was wrong, although we didn't get there. This should be dots. Okay. This doesn't get updated. Pos -1. E line should get set to that. Num A line gets set. This one's length gets set to that. E line gets set to pos -1. Ah. Okay, that's just the assert being wrong. No, it's not. Right, it's inclusive, it's exclusive, so that should be the correct math. So that needs to get set to pos, not pos -1. That's why. Okay. All right. Delete the end. Nope, it left a split here. Delete the end. Delete the middle. Delete everything. Rebuild. Yeah, it's left a seam, so there's like a phantom 0 length one somewhere. Although I don't know why it doesn't render it, because the 0 length one should still render as a bar. Do it in a different spot. Delete the middle. Wait. I did it in a different spot in this. Oh, this might be the boundary of the, yeah, this might be the boundary of the world. I just didn't notice it was already split when I started. That's the, not the world, but the chunks. Yeah, so that's a chunk boundary. Okay. So we can ignore that seam. That was fine. So we delete an end. Looks good. We delete an end. Looks good. Delete the middle. Looks good. Rejoin. Looks good. Oh, that's a seam. Place them there. Place them there. All right. It looks like that's working. Now we have to deal with rotation. We computed pause wrong. How could we get computed pause wrong? Oh, these are less than equal to's. That's wrong. That's wrong. We computed pause wrong. We computed pause wrong. How could we get computed pause wrong? Oh, these are less than equal to's. That's wrong. Probably could have caused a bug somehow there, but I don't know how. All right, so let's take an isolated one, rotate it. Nope. Didn't have item match. The direction would have been north. Is that 2? No, it's 1. Okay. Why didn't I hit it twice? Here. 2. Although I don't know why it doesn't render it. It's a 0 length one. Delete the middle. Wait. Huh. It's the, not the world, but the chunks. Yeah. Looks good. We delete an end. Oh, that's a seam. Place them there. All right. It looks like that's working. Now we have to deal with rotation. Rotation. Now we have to deal with rotation. Now we have to deal with rotation. Like that's working. Now we have to deal with rotation. We computed pause wrong. How could we get computed pause wrong? Oh, these are less than equal to's. That's wrong. Oh, these are less than equal to's. That's wrong. To's. That's wrong. probably could have caused a bug somehow there, but I don't know how. Alright, so let's take an isolated one, rotate it, nope. Didn't have a match. The direction would have been north. So 2? No, it's 1. Okay. Why didn't I hit it twice? Why would its direction be? Oh, that's the old one. Splitting a belt. The old direction was 1. And it wasn't found. Okay. Why didn't I hit it twice? Why would its direction be? Oh, that's the old one. Splitting a belt. The old direction was 1. And it wasn't found. Oh, I don't have access to this. Oh, right, that's what I wanted. So subtract 1. Okay, so it's a 2 long array. There's a belt that is 4 long, and there's a belt that is 1 long. But its direction is still 0. But I already rotated it once. Should have updated its direction. Did I not actually handle that? I think I did not handle that. So we update the block. Did I not actually handle that? I think I did not handle that. So we update the block called create belt. If it already exists, we never update the direction. Are we supposed to do that? So the old one gets isolated, boom. Create belt should probably be responsible for fixing the direction. Else. Okay, direction. Yeah, we do it explicitly here. All right. Yeah, because my debug view does. Yeah, because my debug view does not show me which direction the belt it thinks the belt is. So let's fix that by drawing the first edge in a different color. Can we do that? Yeah. Should be green. It should be greener at the front. All right. It should be greener at the front. Nope. I did not do it correctly. Oh, that had I had it in the right order. I just misthought it. RGB. Okay. Right, it's green at the back, not the front, because I did it wrong. And let's make the back be yellow. So it goes from yellow to green. It's a marathon. Of course it's still going. Marathon. Of course it's a marathon. Of course it's still. It's a marathon. Of course it's still going. What are we at? 3.5 hours. All right, so it's green at the front and yellowish at the back. It's a little subtle. That's fine. Okay, so make one. All right, so it's green at the front and yellowish at the back. It's a little subtle. That's fine. Okay, so make one. Maybe the green and red was actually better because you could tell which end was which. We rotate it. Oh, I actually have to point at it. Yeah, and the green, I could see this green swap. Green swap. Green swap. All right, now let's check about. Since the selection box is green, I should probably just use a different set of colors too. Anyway. Okay, those directions worked. Let's just make them like this. All looks good. Yep, it looks like it's tracking all that correctly. All right. Let's put that on a toggle. All right. Let's put that on a toggle. Put that on a hotkey. And check it in. All right. All right. I'll go ahead and push that. Not that anybody is actually going to get it. And I'm going to take a 1-minute break now. I'm going to take a 1-minute break after I check my email real quick. Oops, I should delete that without reading it. Okay. So yeah, I'm gonna go get my food. Here, I'll just leave, I'll leave this running so that there's something to look at. No, not that, this is going to take me a long... I'll leave this running. Here, I'll just leave, here, I'll just leave, I'll leave this running so that there's something to look at. Not that, this is going to take me longer than a minute to set up, probably, so that's probably dumb, but whatever. Oh, I should go the other way, actually. It'll be faster. No, it won't be faster. Oops, I just lost an update. There we go. All right, I'll be right back. Oh, I missed one. Stop the stream and Okay, I think I'm going to stop the stream and restart it so that the YouTube upload won't be too huge.